So example 10.1.2, so finding the equation of the line of best fit. So we're going to go back and use the data from example 10.1.1, where we've removed the O'Doul's non-alcoholic beer, to do the following. So part A says to find the equation of the line of best fit. All right. So again, we're going to define our variables here to begin with. So in this case, we are using alcohol content is going to be our explanatory variable, and number of calories is going to be the response variable. So that means we're going to put the values of alcohol content, I put in L1, and the values of number of calories, I put into L2. Okay, so again, if you put your data someplace else, then these, again, you would need to make that adjustment here for where you put your lists. Again, I highly suggest that you pause the video here if you do not have two lists of data entered, and to go back to 10.1.1 and to enter those data points again without the O'Doul's beer in that list to make sure that your output screens match the ones as we move forward. Okay, so from the previous video here, again, it's important that you have typed a Y1 here. The default on the screen when like straight out of the box is this is left blank. So again, if you do not have a Y1 there, make sure that you type variables right arrow 1 and 1 to put a Y1 there. That's just going to give us a place where the calculator is going to store this equation, because it's going to have a bunch of decimal places in each of those coefficients, so that we can look at its graph and use it to estimate values for Y in future problems. And again, I'm just going to emphasize on these output screens that this is really Y hat, as we're using these features in statistics. These are estimated values of Y. So again, once we have our lists in there, frequency, the default is 1 there, and we should not change that, so that should still be a 1. This beta and rho here, this is for hypothesis testing later. Right now, what you have highlighted there doesn't matter. If you want everything, including like the t-score and p-values here, which we will talk about in 10.3, those values we're just going to ignore for right now. But those are the only two values on this output screen that will change depending on what is highlighted here. But those aren't the values that we're after right now. So when we hit calculate, the things we're after, we are after this equation. So this equation of the line of best fit is this Y hat equals A plus BX. And so to write that equation, we need the value of A, and we would need to scroll down to get the value of B. Now, in StatCrunch for bigger data sets, again, you can use stat, regression, simple, linear. And again, you would have to have had those two lists of data and pick your X data for number of calories and the Y data, the alcohol content. And again, we can see here that those coefficients are in here as well, where instead of using the variables Y and X, they actually put there the names of those variables. So alcohol content here was our X, and calories here is our Y. Okay. And again, the sample size here is only 9. Again, initially we had 10, but we took out the O'Doul's non-alcoholic beer. And there's some other things featured on this output screen too that we're going to learn what those other numbers mean throughout 10.2 and 10.3. But right now we're just after this equation of the line of best fit. And so if we take those coefficients, we're going to get 25.031233606 plus B, which is 26.3186076 times X. And in this case, I write too big, I filled up the line here. We need X to be between X min and X max. And so if we go back to the list of data, we will see that the smallest alcohol content was 4.15%, and the highest was 8.1. All right, so part B says to draw the scatter plot and the line of best fit on the same set of axes. Now, since we told the calculator to store that equation in Y1, if you push zoom 9, you will see the scatter plot and the line of best fit drawn on the same set of axes. All right, now this assumes that you actually followed through the instructions on the first page where we did the scatter plot for that data. Otherwise, if you push zoom 9, you might not have anything there. It might be something from some prior problem. So make sure you go back to the very first example where we made the scatter plot initially. And again, deleting the O'Doul sphere. We're only looking at those 9 data points. And again, whether we're looking at that in StatCrunch or if we're looking at that on our calculator, we will see that in both cases we have this line of best fit. Okay, so this is our line of best fit, which we're going to discuss what qualifies it as the best fitting line here in a second. But you'll notice that there's a bunch of these points it doesn't even pass through. So there might be one in here, but even those, it looks like it kind of splits right down between them. So this line of best fit doesn't even appear to touch any of the points in the data set at all. But of all the lines possible, using this criteria we're going to get into, this is what we consider the best fitting line for these 9 data points. So now if we interpret the slope and the y-intercept in the context of this data, so slope is change in y over change in x, which in this case is going to be the change in number of calories over change in alcohol content. And so if we round that off, it is about 26.32 over 1, where the units here are calories and alcohol content was a %. So the slope here tells us that for every 1% increase in alcohol content, we expect the calories, since the slope here was positive, we would expect those calories to increase by 26.32 on average. And the y-intercept here would be 0%. We plug in 0, and the output there was 25.03 calories. So again, this has no meaning with respect to this problem since we're only looking at alcoholic beers. So it makes no sense to talk about a beer with 0% alcohol. Okay, so again, the key thing on these, the relationship that we're really interested in is the relationship described by the slope.